And so now we have come to the heart of geometry, deductive reasoning. This is a skill that is tricky to learn. However, learning this skill will put you leaps and bounds ahead of the average person when it comes to intelligence. Sherlock Holmes' only skill was that he had mastered deductive reasoning. Now it's your turn to do the same. Deductive reasoning is often called logical reasoning. It is the process of reasoning from true statements to a conclusion. The first property of deductive reasoning is called the law of detachment. It says that if the hypothesis of a true conditional is true, then the conclusion must also be true. That seems very intuitive for a logical property. We can demonstrate this property using symbols. If the statement P implies Q is true, and P is true, then Q is also true. Let's try this using an example. What can you conclude from the given true statements? So notice that these statements are true. If a student gets an A on a final exam, then the student will pass the course. Something that's very important to remember is that the hypothesis and the conclusion of a conditional are each a complete sentence by themselves. What we're going to do is to see if our second statement matches our hypothesis. A student. Well, Felicia is a student. Gets an A. Well, Felicia got an A on a final exam. Well, Felicia got an A on her final history exam. Notice how our second statement matches our hypothesis. So P is true. That means that Q is also true. Our conclusion has to be true. So the student in our conclusion is Felicia, will pass, and in this case, the course is history. Can you see how our second statement here matched our hypothesis in the original conditional? That is what is important with the law of detachment. Let's see what we can conclude from these true statements. Once again, notice that these statements are both true. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. So we have a hypothesis and a conclusion. And what we need to do is check to see if our second statement matches our hypothesis. Well, notice we need a ray, and we do have ray RS. And that ray needs to divide an angle. Notice that ray RS divides angle ARB, but it has to divide it into two congruent angles. Well, notice that it divides it so that angle ARS and angle SRB are congruent angles. Let's draw a figure here real quick to make sure that we have what we're looking for. This is angle ARB, and this is our ray RS, and angle ARS is congruent to angle SRB. So indeed, ray RS divides angle ARB into two congruent angles. Our second statement does match our hypothesis. That means we can make a conclusion based upon the conclusion of our original conditional. So we have the ray, which we know as ray RS, is an angle bisector. There's nothing special to this. There's really no thought that has to go into it. You check to see if the second statement matches the hypothesis in the conditional. Then you just plug in the name of the specific object into your conclusion, and you're done. Let's try one more. What can we conclude from these two true statements? If two angles are adjacent, then they share a common vertex. So here we have our hypothesis, two angles are adjacent, and our conclusion, they share a common vertex. Does our second statement match our hypothesis? Our second statement says angle 1 and angle 2 share a vertex. Well, I'm looking at my hypothesis, and there's nothing in there about things sharing a vertex. So, no, our second statement does not match the hypothesis. Therefore, we can make no conclusion. Now, some people get tricked into believing that this matches the conclusion. Therefore, the hypothesis has to be true. But that doesn't work at all. Remember, the law of detachment said if the hypothesis is true, the conclusion is true. The law of detachment does not work the other way. So if the second statement does not match the hypothesis of the conditional, you cannot make a conclusion.